All right, so let's finish up our discussion here of fresh air ventilation systems by addressing the question of fresh air flow rates. So we've done a pretty good job here of setting up our actual system components themselves. So we've built out the ventilation unit, the HRV. We have set up all the ducting, and we've set up the type of system, balanced ventilation system, all that kind of stuff. But the one piece that we haven't quite sorted out is the fresh air flow rates. Although we've started on that, but let's take a look at that question in some depth here in this last video. So as we saw when we opened up the PHPP last time, there was a whole bunch of flow rates that were showing up there. So we had a lot of flow rates that were being input. So let's take a look at that one more time. So let me come in here and let me open up our PHPP and let's see what we see there. All right, and as soon as this is booted up and loaded up, let's go and take a look at our PHPP. So this is our PHPP. I am in the additional ventilation worksheet. And as I said, in the additional ventilation worksheet, sort of at the top here, the first section has to do with dimensioning of air quantities, flow rates. What are the flow rates for the different rooms? So we have our breakdown of all of the different rooms. We have our areas and our ceiling heights, which gives us the volume. And then we have a whole series of flow rates. So supply air, extract air, and transfer air. And notice they're all the same for each room. And each room has a different number. In addition, each room has a schedule applied to it. Where do these numbers come from? These numbers don't look a lot like the numbers we entered. What do I mean by that? Let me hide this for a second, and let me go back into our Rhino scene for just a second here. If you remember, in our Rhino scene, if I come into any of my individual elements and I go to, let's say, room 202, bathroom, and I come up here to the Tfa parameters, and I go to Tfa parameters, remember, we input a flow rate of 44 cubic meters per hour at 100% boost. And that's what these numbers are. So these numbers are at 100% fan speed. So we always enter these numbers at 100% fan speed. So 202, let me go back to my Rhino, 202 bathroom is supposed to have an extract of 44 cubic meters per hour and a supply of 0. Well, if I go to my PHPP, room 202, which is this right here, has a supply of 7 cubic meters per hour, an extract of 7 cubic meters per hour, and a transfer air of 7 cubic meters per hour. None of those are 44. So what's happening here? How come our information is not flowing through? Well, what's happening here is that by default, until we tell it otherwise, both the Honeybee model and our export is going to ignore all of that information in favor of the PHPP, or excuse me, the Honeybee program. So what does that mean? Well, if we come over here to our Create Honeybee Rooms and we zoom in on our room, any of our rooms, so remember we have our geometry that flows through, we create faces, and the faces get combined to make a room. And we had the option when we set up the room to input a program type. We chose not to input anything, and so by default, Honeybee is going to assign a generic office program. So unless we tell it otherwise, Honeybee assigns a generic office program to all of the rooms which are created, and by default, unless we tell it otherwise, that program is what is used to calculate or determine those fresh air flow rates. So all of the programs which are built into Honeybee have fresh air flow rates in them. How can we see that? How can we take a look at that? Well, let's see. For instance, we can use Honeybee Energy tools. So if I come into Honeybee Energy, and let's see, to see the program, what do I need to do? I guess I need to, we want the room energy attributes. Is that what I want? Yeah, room energy attributes. And I guess I need to go back to regular Honeybee and say Honeybee rooms by attribute. Is that how I get this? Let's see, room. Let's find out. So I'm going to take room. Whoops, what just happened? Oh boy. Okay, whoops, accidentally connected Honeybee objects to here. So anyway, I want to take room and connect it to room. And then I want to see the program. So I want to see what program is assigned to those rooms. And if we take a look at the values here, notice that so it's a generic Office program, right? So as I said, unless we specify otherwise, unless we tell it what program to input, it's going to apply this generic Office program. And so I can see the ventilation parameters of this generic Office program, again, by using the Honeybee energy components. If I come up here, where do I get that? Let's see, basic properties. Do I have to search? No, that doesn't seem right. I think I can I think I can go to loads and deconstruct program type. That's what it is. So go to loads and deconstruct program type. And if I feed that in as the program, feed that in as the program, notice over here, I can now see a bunch of information about the people, the occupancy, the lighting schedule. We're most interested in this ventilation information. And so the generic Office program has a ventilation load of a certain amount of airflow per person. So I believe these are cubic meters per second. Do we get that information here? No, but I'm almost certain that that's cubic meters per second. And a flow per area, and then there's a couple of other ways that Honeybee sometimes configures ventilation depending on the type of program. So different programs are going to have different numbers for these. In any event, though, this information is what is currently being used to determine all of this information. So based on the occupancy, based on the size of the space, all of this information is being calculated, based on these loads. So again, by default, all of the Honeybee programs are going to determine those flow rates. Let me delete all this. That was we were just looking at, we were just viewing. Now, of course, we can come in here and we could apply a different Honeybee program. So for instance, if we were to apply a different Honeybee program, we could absolutely adjust those flow rates. So for instance, if I came in here and I said, let's see, search building programs, let's see, Honeybee program type, whoops, no, not that one. Building programs, let's see, what do we have? Large office, small office, mid-rise hotel, high-rise apartment, retail, primary schools, small hotels, outpatient, supermarket, courthouse. So no single-family home. Closest we have are probably this mid-rise apartment, and if we feed in mid-rise apartment, notice that we'll have a couple different program types that come out. We have a corridor, or we have corridor, office, and apartment. So let's see, we could use our item selector, and we could select just one of these. Let's say we want apartment, and then we could apply apartment to our program here. And so as soon as I do that, this will go off and recalculate everything, and it'll update all of those flow rates. So let's remember what flow rates we were set at here. So let's say, for instance, 202 bathroom was set at 7 cubic meters per hour. And let's see what happens when we just apply this updated program to our set here. And this will go off and calculate for a second, and as soon as it's done, we'll see the results in the PHPP. Okay, so that just took a second to calculate, and let's load up our PHPP now, and let's see what we get. And everything's reorganized here. That's fine. Where are we? 202 bathroom. Now we're down to 5. So we've gone from 7 to 5. So large office had us at 7 cubic meters per hour. Mid-rise apartment building, apartment has us at 5. So this is all determined by the program type. But as you saw, there's no single-family home here. I would like to be able to load up a typical single-family home, a passive house style type, but we don't have that. In addition, for passive house buildings, we're almost always going to be using the so-called Cascade ventilation approach. So to go back to our PHPP for a second, notice that in the basic approach to ventilation, the sort of typical construction approach, we would supply fresh air to a space, and we would extract fresh air to a space. That's not typical for how we do most of our passive house buildings. Usually we're going to supply air to certain spaces, we're going to extract air from different spaces, and then we're going to allow for transfer air to carry between them. This is the so-called cascade ventilation approach. It allows us to reduce our flow rates to a much lower level, improving indoor relative humidity in wintertime and summertime, and reducing those flow rates, so reducing energy loss and energy consumption, while maintaining really high indoor air or indoor environmental quality. So that method, that approach, that cascade ventilation approach, can't really be captured by the standard Honeybee tools. So in those cases, we need to go with our passive house tools, our sort of updated tools here. And so none of this is, we don't want to use any of this stuff. I mean, we could, but in most cases, we are not going to want to use this for most of our certified passive house projects. So let me go ahead and delete all of this, and let's get us back to square one. All right, so we're back to a small office schedule for a program for our Honeybee room, and that's fine because we're going to ignore it in a second. So how are we going to ignore it? How are we going to say to our definition here, do not use the Honeybee program. Instead, use the values that I explicitly set through my TFA input. Well, it's pretty straightforward. In order to do that, all we have to do is come over to our space, and we have an input here. Notice we have an input here for ventilation flow rate source. And we can say that we want to get our flow rates either from the Energy Plus programs. So by default, it's the Energy Plus or Honeybee programs that we're going to use as the source. We can override that and say, no, don't use those. Instead, use my user-determined flow rates. And in order to assign those user-determined flow rates, all I have to do is input the text or the string UD indicating user determined. So let me go ahead and hook that up, and as soon as I hook that up, you'll see that this will go off and update our PHPP. It's going to recalculate all of the ventilation flow rates for all of the spaces on the second floor. It's going to push that through the entire Honeybee model, and it's going to update our PHPP out the back end as well. So it looks like it's done updating, so let me go over to our PHPP and let's see what we got. And notice now we have a very different situation, don't we? Our bedrooms are at 0, 0, 0. Well, we didn't apply anything. Bedroom 0, 0, 0. Bathroom 0 supply, 44 extract, and 0 transfer. So very different results. Why are some of them still showing up as Energy Plus? Well, because we only, go back to our definition, we only told the second floor PHPP spaces to take as their vent flow rate source the user determined values. So if I come down to my lower element here, let me kind of move these guys around a little bit. I'll do the same thing down here. I'll say user determined for the flow rate source. This will go off and do a bunch of calculations. It's going to recalculate the ventilation flow rates and the volumes for everything. It's going to pull all that information out of our Rhino scene, and then it's going to have all that data flow through the entire Honeybee model and then into the PHPP as well. So now that's all done. Let me go load up our PHPP, and notice everything here in our flow rate section has been significantly modified. So we are no longer taking our flow rates from the Honeybee programs or the Energy Plus method. We are going to use, or we are using, our explicit cascade ventilation approach here to configure exactly the amount of airflow that we want in the different spaces. So notice here I'm pulling air out of some spaces. I have not yet set up any supply. So now that I know what my total extract is, so if I have a total extract of 194, I can go through and distribute that supply amongst all of the various rooms and spaces inside of our project in order to balance out the ventilation. But we start with the extract and then we distribute the supply to the various bedrooms and living rooms and what have you. So let's go ahead and do that just to drive home the point there. So we have what did I say? We have 194 cubic meters per hour to distribute amongst all of our various spaces. So let's do that. Let's come into our Rhino document here. We minimize our grasshopper and let's distribute some of that airflow. So let's come in. Let's say room 201. Room 201 is a bedroom. That should have, let's see, we have 194. So let's say that this gets 40 cubic meters per hour of airflow. It's bedroom. We want good ventilation in the bedroom. Let's do the same thing in this other bedroom. Let's say we have another 40 over here. 40, 40, so 198 minus 80, so we have 108 left, or 118 left, excuse me. And what else do we want to supply? Where else do we want to supply? Definitely the den, so the den should definitely, let's say the den gets another 40, so we'll do 40 into the den. And let's see, and then I suppose the balance should go into the living room. And so where are we at? I guess we're at like 80 into the living room. We'll check that in our model. So I've now entered a bunch of supply information in my model, and let me force this to recalculate. So let me what are we going to do? We want to reload our TFA surfaces. So we'll push the TFA surfaces in again. That's going to force this to reload, and it's going to sort of go back to Rhino and reread all of that information. Again, if I had been using something like a geometry pipeline for my grasshopper scene here, then this would update automatically. But because I'm using an explicit reference, I have to sort of force the update to push through. And we'll do the same thing with our upper story there. So we'll take all those upper level TFA surfaces and push those through. We'll recalculate all of the space airflow rates and push that through our Honeybee model there as well. And then let's see what we get in our PHPP when this is all done updating there. So let's take a look at the PHPP. All right, good. So did I get the right amount? We're at 200. Well, we're at 200, and this one's at 194. So that's pretty. That's close. We could tweak this. We could, set this to 72 or whatever that would be. Did I do that right? 192, sorry, 74. So now we're perfectly balanced. We could go back and make this change. We should go back and make this change in the Rhino document as well. But of course, I can always circle around in the PHPP, mess around with this stuff as well. In any event, we have now significantly updated our airflow rates. Let's see, what's our, look at that. Our total ACH is at 0.7 right now. That seems really high. Well, the reason that's high, so all of this updated, all of this changed. The other thing that changed, if you look over here to the right, is that the schedule changed significantly. Right now, the schedule is set for 100% flow rate, so the maximum flow rate, running 100% of the time. Well, that's not correct. Normally, we would say we want this to be our boost. This is our maximum possible flow rate, but we don't operate it at peak flow rate 24 hours a day. We would operate it at maybe 75%, 77% fan speed, maybe 50% fan speed for most of the day. Then we might even have an away operation. We might even have like a vacation mode where we could turn the fan way down low, and so we run it 15% of the year, 10% of the year on ultra low flow, whatever the percentage is that the people are away. In any event, we would never run it at 100% fan speed 100% of the time. So how are we going to set up this schedule now? Remember, we told our Grasshopper tool, no, don't take any information from Energy Plus or Honeybee. I want it all to be user determined. Well, okay, so in that case, we actually need to set up a PHPP Event Schedule. And notice here that we have an input for PHPP Event Schedule. Okay, so we need to set up a schedule now because we are no longer pulling any information from our Honeybee program. So let's set up a quick ternary schedule. Come over to Passivhaus Tools, we'll come to O1 Model, and I'll come down here to Create Room Vent Schedule. And so this is a new component, so we've got a whole new component here, which is going to allow us to kind of put it down in the middle here, I suppose. It's going to affect, I want it to control both, let me do it this way, I'll make this a little bigger. I want it to control both sets of ventilation, so I'm going to sort of put it in the middle here so it can sort of feed both. I guess I could like put it way over on the side or something, however you prefer. In any event, we can set up this schedule. So how is this schedule currently configured? This schedule is currently configured to run 100% of the time at 100% fan speed. Okay, well that's not. So that's not what we want. So we need to adjust this operation time high and operation time medium. Let's say, for instance, I want the system to run 23 hours a day at medium fan speed and only an hour a day at boost fan speed. So what would that be in terms of percentage? I have to input this in terms of percentage. So let me just do this. I'll use an expression and we'll just do that math here. Let's just say 23 divided by 24. So 23 hours of the 24-hour day gives us 0.95833%. Okay, fine. So that, I'm going to input that as my operation time for medium. Notice here, time medium, 0.95833. And what I need to do is then do a corresponding time. So 1 hour a day of the 24 is what? Is 0.04%. And that is the amount of time that I want, oops, not fan speed, operation time. That is the amount of time I want it to operate at high speed. So at high speed, it's operating 1 hour out of the day, and at medium speed, it's operating 23 hours out of the day. It's never operating at low speed. We could change that schedule. If you don't like that schedule, you can make up your own schedule, whatever works best for you. But what I'm going to do now is I'm going to take this schedule, and I'm going to connect the schedule to this ventilation, this PHPP-Spaces ventilation, and this PHPP ventilation schedule in PHPP-Spaces. So let me lock this quickly, and I will apply it there, and I will apply it here. And then once they're both hooked up, I'll just unlock. The only reason I locked it was just so that it wouldn't update and recalculate the entire Excel when I connected the first one. Since I knew I was going to connect it twice, rather than having it go through the entire update and calculation sequence twice, just did it the one time. In any event, everything's now updated and pushed through, and if I go back to my Excel document and to take a look at Excel, notice all of this has been updated, so now it's running at 100% fan speed 4% of the time, and 77% fan speed 96% of the time, and that's true for all of the spaces here. So now if we come up to the top, let's take a look. Now we're at 0.56 ACH, much more modest, much more. So that seems about right. We would typically shoot for something like 0.4 to 0.5, maybe as high as 0.6. This is getting a little high. We might have some trouble with overly dry air, except this is an ERV, so I'm not super worried about it in this case. We can obviously evaluate that much more closely later on. In any event, we have now set up all of our flow rates and all of our schedules. We've discussed how we can use the Honeybee. Let me delete this. We can use our Honeybee programs to control this if we like, or we can use our schedule. We can make an explicit PHPP schedule and apply it to our spaces here. And as always, all of that is flowing through into our Honeybee model and our PHPP. So all of that is updating all the way along this entire chain. So at this point, we have an awful lot of information. Let's take a quick look at our PHPP, and then we'll finish, because this one is getting awfully long. We go to our verification worksheet, and we take a look now. We have our TFA. We're getting some heat demand numbers. We're getting some heating load numbers. If I was to go to the heating worksheet and kind of scroll down towards the bottom here, we get our nice graph that shows us at a glance what's happening. I guess I need to make it even bigger. There's never enough room. And so we've got all of our losses on one side, all of our gains on the other. So solar gain, window losses, ventilation losses. Ventilation losses are looking pretty high. We might want to see what's happening there. We might want to dive in a little bit further. Yeah, so we're only at 79% heat recovery, 0.56. I guess 0.56 is a little bit high. Why are ventilation losses so high? Oh, I know why. If we go to ventilation, Notice that our air tightness is still set to 4.4 ACH. So that's one of the reasons that our ventilation losses are so high. So we'll come back and set that in later sections. We can set up air tightness, we can set up our summer ventilation, set up all sorts of additional things. But the main thing here is that this is all working. We're getting all of our losses, all of our gains, we're getting our final heat demand, we're getting cooling demand, overheating risk, etc. All of that is flowing through properly from our Rhino document. So everything seems to be working pretty good at this point. So I think we will bring this one to a close. Hopefully everything is working well on your side as well, and you're getting reasonably close results. You know, obviously if your building is a little different, have some different values somewhere, you might be getting some slightly different answers, but hopefully you're at least reasonably close, able to sort of follow along here as we go. All right, so that will bring this one to a close. When we come back in the next series of videos, I think we'll finish up our discussion of systems, or maybe not finish up, but we'll continue our discussion of the systems of the building. And I think the next thing that we should turn our attention to is the domestic hot water system. So for a small house like this, domestic hot water is obviously going to be a big piece of the puzzle when it comes to overall annual energy consumption. It's obviously really important when it comes to summertime comfort and overheating risk. So we will turn our attention in the next video series to the question of our domestic hot water system. We'll look at tanks, we'll look at piping, we'll look at insulation, we'll look at usage profiles, we'll look at all the different aspects of a typical domestic hot water system. So I will see you back in the next video, and we'll continue on with our modeling.